Welcome to question 7 of the 2011 Mathematical Methods Exam 1. In this video we will be looking at the solution and examination advice for this question. A reminder that this video is in no way endorsed by VCAA. So for question 7 we're told a biased coin is tossed 3 times. The probability of a head from the toss of the coin is P. Find in terms of P the probability of obtaining, and for part 1 we want 3 heads from the 3 tosses. So just before we go too far into this question, we can see that this distribution would be a binomial distribution, and for a binomial distribution with n trials and a probability P of success, we have the probability that x is equal to a number of successes is equal to n choose x times the probability of success to the number of successes times the probability of failure to the remaining number of trials, or n minus x. So for this question we know that x is distributed binomially with an n value of 3 trials, and a probability of getting a head from a toss is p, so that is the distribution. So therefore the probability that x equals 3, that is that we get 3 heads, is equal to 3 choose 3 times the probability of success to the power of 3 times the probability of failure to the power of 0. And simplifying that, we know that 3 choose 3, there's one way of doing that, so that number is 1, and anything to the power of 0 is also 1, so we just get that this is p cubed. So that is the answer to part A of this question. For part B, we still have x is distributed binomially with 3 trials and a probability of obtaining a head from a toss of p. And now we're asked for the probability of 2 heads and a tail, so the probability that x is equal to 2 heads is equal to 3 choose 2 to be heads, multiplied by the probability of success to the power of the number of successes, which is 2, and then 1 minus p, the probability of failure, to the number of failures, which is 1. And that would simplify to 3 choose 2, there's 3 ways of that happening. So this is going to be 3p squared times 1 subtract p. And that is the answer to the second part of part A. From the examiner's report we can see that 71% of students got part 1 correct, and it was mostly well done, although some students wrote p times p times p is equal to 3p, and that was a common incorrect response. There are also a number of responses where students incorrectly assigned a numerical value to p. For part 2 of part A, we can see that 41% of students got that mark, with 59% of students not getting the mark for that question, and the majority of incorrect responses neglected the 3, which takes into account the number of possible arrangements for 2 heads and a tail, which could have been head, head, tail, or head, tail, head, or tail, head, head, and that was easily calculated as being 3 choose 2 on the previous slide, and that comes out to be 3. For part B it says if the probability of obtaining 3 heads equals the probability of obtaining 2 heads and a tail, find the value of p. So those two outcomes relate back to part A of this question. So we're going to say that p cubed is the probability of obtaining 3 heads, is going to equal 3p squared times 1 subtract p, which is the probability of obtaining 2 heads and a tail. So to solve this we're going to get it onto one side and factorise, so we have p cubed subtract 3p squared times 1 minus p is equal to 0. And now p squared is the highest common factor between the blue term and the green term. So we have p squared times, and left behind in the blue would be p. And then for the green we'd have minus 3 times 1 subtract p. And that expression would equal 0. So therefore, if we do one more line of simplifying, we'd have p squared, and then in brackets, we'd have p minus 3 times 1 minus 3 times negative p. So that will actually give p plus 3p is 4p minus 3 is equal to 0. And using the null factor law, we can say that p could equal 0, or p could equal 3 on 4. And now thinking back to the question, we knew that it was a biased coin, so it's possible that p equals 0 or p equals 3/4. And then thinking about the next part of the question, is the probability of obtaining 3 heads equal to the probability of 2 heads and a tail? And for p equals 0 and p equals 3 and 4, they are the two values where those two things are equal. So that makes those two values the solution to this question. From the examiner's report, we can see that 18% of students got full marks for that, with 58% of students making some progress in the question. The examiner's report goes on to state that cancelling out of P was rarely supported, and that many students incorrectly assumed that P could not be 0. And in this case, because it was a biased coin, it could actually be 0, and that solution was expected in this question.